Okay, quick math check. We are about to run pH calculation, and this requires understanding of logarithms in advance. If you are currently taking Algebra 2 or higher, you may have already learned about this logarithms already. And if you did, then you're in good shape. But if you're taking geometry right now or below, okay, if you have not learned about the logarithms yet, then I strongly recommend you guys first watch the video that I provided the video link for it. To first teach yourself about the logarithms. Okay, this is a very short video, less than 4 minutes, and it's explained very well. Okay, calculating pH and POH. pH and POH just tells you how much of concentration of hydrogen or hydroxide is in a given solution. Okay, and this can be mathematically done. pH is equivalent to negative log base 10 of the concentration of hydrogen, and the POH is negative log of concentration of hydroxide. The relationship between the pH and POH. When you add the pH and POH of the same solution, it's going to be always 14. Finding concentration of hydrogen or POH from pH and POH. This, you just basically have to do the reverse of calculating pH, POH. Concentration of hydrogen is 10 to the power of negative pH. And concentration of OH is equivalent to 10 to the power of negative POH. So this is basically a picture to show you the relationship between the pH and POH. So let's say that you happen to find out the pH level of a solution, which happens to be 2. And then for the same solution, the POH can be very simply calculated. Since the pH is 2, the POH has to be 12, because when you add these two together, right, it has to be always equivalent to number 14, right? Same with water. Water's pH level is 7, and that means the POH has to be 7 too, because when you add them together, number has to be 14. And this is the basic picture to show you how to convert from one to the other. And you're gonna have to master this, okay? This actually, the picture is not gonna be, conversions are not gonna be given to you for your chapter exam. So you are responsible to know how to convert one from the other, okay? So this is basically converting between the concentration of hydrogen, concentration of OH, and then pH and the POH. Well, the pH and POH conversion is pretty simple, right? Because you just have to subtract the pH or POH from 14 and you get the other one. Okay, and then the other ones, it requires some practice, but once you guys do some practice problems, these should be pretty easy, straightforward. Okay, so this actually reminds me of the conversion that we used to do with moles. If you guys remember the conversion between the moles and the grams, and also the number of particles, right? And then we have to go back and forth, right? We used to call that a triangle of death, right? So this is basically an extended version of that. So I'm gonna call this one the square of death. Ha ha ha. Okay, now for the practice of the square of death. So pH and POH practice problems. A 1.0 times 10 to the negative 4 molarity solution of HNO3 has been prepared for laboratory experiment. Calculate the concentration of hydrogen of the solution. Okay, well, you have to first realize that HNO3, right, is going to be a strong acid. Okay, and strong acid, which means that it is essentially 100% ionized in solution. So every time you have a 1 mole of HNO3, it's going to completely break down or dissociate into hydrogen and NO3, right? So if you have 1.0 times 10 to the negative fourth power of molarity of HNO3, right, it's going to dissociate, break down into hydrogen and nitrate. So you are going to have 1.0 times 10 to the negative fourth power molarity of hydronium ion. Now, based on this, let's go ahead and calculate the OH minus. So this is time you got to use your square of death to calculate how to calculate the OH minus from H3O plus, which is also known as a hydrogen. Okay. Kw is equivalent to concentration of hydronium, or also as known as hydrogen, times the concentration of hydroxide. So to calculate the OH minus, you have to work with the equations to put the Kw over concentration of hydrogen, and Kw is constant. Okay, you have to memorize that. 1.0 times 10 to the negative 14th power divided by 1.0 times 10 to the negative 4th power, which will then give you 1.0 times 10 to the negative 10th power molarity. Okay, another practice. What is the pH of a solution if the concentration of hydrogen is 3.4 times 10 to the negative 5th power molarity? Well, this is a basic pH calculation out of a H3O concentration. So pH is equivalent to negative log of concentration of H3O plus. Go ahead and plug in your number, 3.4 times 10 to the negative 5th power, and then reporting two significant figures, you get 4.5. Determine the hydronium ion concentration of an aqueous solution that has a pH of 4.0. Now, this is going backwards. I'm asking for the concentration of hydrogen, right, based on pH of 4.0. So I'm going to go ahead and first write down the equation, and I'm going to have to calculate the concentration of hydrogen. So let me go ahead and get rid of this negative log. I'm going to divide both sides by negative first, and then I'm going to take the anti-log on your calculator. If you don't have an anti-log calculator, this is basically, anti-log is same thing as 10 to the power of negative pH. Okay, some of your calculator will have a button that looks like this, 10 to the x power. That's the button you should be using. So I'm going to go ahead and put the 10 to the negative pH power, and this is equivalent to, well, actually this is a mistake. This should be actually two significant figures, right? So this should be actually 1.0. 1.0 times 10 to the negative 4th power molarity of H3O plus. Okay, what is the pH of 1.00 times 10 to the negative 3rd power molarity of barium hydroxide solution? This is a really good problem, so pay extra attention if you want to do well on this chapter exam. First of all, barium hydroxide is a strong base. Okay, again, this is one of the 6 species you have to recognize out of strong base, which means that it is essentially 100% ionized in solution. So every time you have a BaOH2, it's going to completely break down into barium and hydroxide ions. But pay extra attention to the 2 hydroxide for every 1 barium. Okay, so 1 molecule of BaOH2 is going to produce 2 hydroxide ions. Take a look at this equation, right? And you will realize that BaOH2 will split into 1 barium and 2 hydroxide ions. And this is important because thus 1.00 times 10 to the negative 3rd molarity of BaOH2 will produce 2.00 times 10 to the negative 3rd power molarity of OH. That's because the molar ratio between BaOH2 and OH is 1 to 2 ratio. So 1, right, becomes now 2. Now, there are 2 pathways to calculate the pH from the concentration of OH. Okay, and depending on the problem, sometimes your answer will be different. they will give you different number of significant figures. Okay, so one way to do this is to first calculate the POH from the OH and then convert the POH into the pH. That's one pathway, taking that a square of death, right? Another pathway to do this one is to convert the concentration of OH into the concentration of H using the KW equation, and then use that the concentration of concentration of hydrogen to convert into the pH, which I'm going to follow the second pathway to do it, okay, for this practice problem. So I'm going to go ahead and use the KW equation to first convert the OH to the hydrogen. So hydrogen is equivalent to KW over OH. So KW is a Reese constant, 1.0 times 10 to the negative 14th power, divided by the OH, and that gives us the 5.00 times 10 to the negative 12th power molarity. Well, KW is a constant, so remember it does not affect your significant figures. Only the given number does. Now, once you have this number, go ahead and plug into the pH calculation. Negative log, and you put the 5.00 times 10 to the negative 12th power molarity, and you'll get the answer 11.3.